that. All right, so 5.4, we're analyzing graphs of polynomial functions. We're going to look at reading the graphs, locating their real zeros, and finding the relative minimum and maximum. So the relative minimum and maximum actually, so back when you first started looking at maximum and minimums on graphs, you've talked about the highest point and the very lowest point, right? The highest is the maximum, the very lowest being the minimum. Relative minimum and maximum actually happen everywhere there's a high point and a low point, okay? So basically the turning points is your relative mins and maxes, okay? It's where I'm decreasing and I hit a turn, that point is now a relative min. As I'm increasing and I hit a turn and go back down, I've reached a relative max, okay? So when there's no other nearby points that have a greater or lesser y coordinate. The extrema is just your maximum and minimum values, but the turning points are the most important thing that we're talking about right here. The points at which the graph changes directions, where it's increasing and decreasing in intervals, right? Anytime you're reading these graphs, make sure you're reading them from left to right. So here I am decreasing, and then I'm increasing, and then I'm decreasing again. Is everybody with me? So I'm reading always from left to right, okay? They are going to ask you a little bit about increasing and decreasing increments on the homework. That's all it is where is it going down? Where is it going back up? Is everybody with me on that part? Okay, so I don't have enough room to write the last little bit here, so I'm going to change my paper, which really means I'm just going to y'all's notebook because I was having you copy that part. Oh, one thing I forgot with the turning points. The turning points help you determine the degree, okay? So if you have, with the turning points, it's the degree minus 1, okay? So that means the degree is how many turning points there are plus 1, right? The turning points is the degree minus 1, so the degree is turning points plus 1. Does everybody make sense of that? That's really important when we start looking at the graphs here in just a second. Okay, so let's look at an example. I'm going to write all the information we're going to look at first, and then we'll look at the example. For A, we're going to estimate the x-coordinate of each turning point. And determine if they are relative max or mins. Missing Alex, I just realized. For B, we're going to estimate the x-coordinate of every real zero. And by estimate, they're probably looking for the nearest whole, the nearest half. Okay, they're probably not asking you for getting anything real small. Okay. For C, you're determining the smallest possible degree of the function. So this is where that turning points plus 1 is going to come into play. And let me just tell you this. If you know it's an odd function, the smallest one is the smallest it could be. It could turn some more and be a larger odd number, but that's the smallest it can be. Is everybody with me? And lastly, you're going to determine the domain and range. Oh, I didn't tell y'all. You know, every Christmas I get the specials and order my new pens, right? I told y'all about that. FedEx says my pen's delivered 2 days ago. I still don't have any new pens. They delivered to the wrong house. And nobody came and brought them to me. So sad. I know. They opened some good pens. It was this kind, and have you ever heard of Rocketbook? So I have a Rocketbook that I use from somebody that takes a certain kind of pen, and you take a picture of it, and it uploads to your Google Drive. So you can take notes, upload it to your Google Drive, and then erase it, and use the same paper over and over and over again. You know what I'm talking about? Okay, so I'm super cool about it, but I didn't have any pens. So somebody on campus was like, oh, I won one time. I don't use it. You want it? I don't have any pens. I was like, sure. So got a good deal on pens at Christmas time. Nope. I still don't have no pens. When it comes in, I will show you though. Because I'm thinking I could take the notes, erase them each class period. Right? Just take pictures of it, goes to my Google Drive. That didn't sound awesome to y'all?
How do you erase it?
You just wipe it off with water and napkin.
Wait, on
Ta-da.
paper?
It's a different feel of paper. When my pens, because I had to reorder, they are reshipping them supposedly. Maybe I'll end up with double. No, I'm kidding. No, I'm kidding. They really got lost. Anyway, they're reshipping them. I'm supposed to have them by Friday, so maybe Monday we can play with the Rocketbook. That would make me happy. All right, I'm gonna draw a graph here, and we're gonna talk about these things with that graph. I'm not gonna draw more than this one because they're just very difficult to draw, but what I am going to do is we're gonna look at another example in the book. I'm gonna pull it up and let you guys look at it. Oh, one more there. Got off a little bit. Pen's not doing so hot here. There it is. Yeah, I'm wide out my mishaps there. There you go. Can't even tell they were there, right? It's terrible drawing, but whatever. It works. So here is my polynomial. It should be curved a little bit more. That's okay. All right, so we're gonna estimate the x-coordinates of each turning point and determine if they are relative maxes or mins. So just like always, I'm gonna read my graph from left to right. I'm looking for the first turning point. Here it is. It asks for the x-coordinate of it. So what is the x-coordinate of that first turning point? -2. Is that first turning point a relative max or a relative min? It is a relative max. Does everybody see that? It's not the highest point on the graph because that's continuing to go on, but it is relative to what's going on here. It increases and decreases on each side of it. All right, and then I keep going, and I've got one down here. What is the x value for that turning point? 1. And it's a relative max or a relative min? A relative minimum. Does everybody agree? All right. Then it says estimate the x-coordinate of each real zero. Real zeros happen when? X-axis. So I've got one here, one here, one here. I'm looking for the x-coordinates for those. So this is where x is -1, -2, -3. Yes. What about this one? -1. And that one? 2. So x equals -3, -1, and 2. Those are my real zeros there. All right, then it says determine the smallest possible degree of the function. How many turning points do I have? 2. Therefore, my degree must be 3. Does everybody agree? What else could it be? Can it be 4?
It could just off the graph.
Could it be 4?
No.
Why not?
Well, look, if it goes off the graph line, it turns.
They're in behavior. What you see right here says absolutely cannot be. It's going opposite directions. The in behavior says it's an odd function. Okay? Is everybody with me? So it could be 3. It could be 5. It could be 7. Is everybody with me on that? Okay. So the in behavior says that it's going in opposite directions. You can't assume 4. Okay?
Repeat that again. I didn't get that.
They're going in opposite directions, so it had to be odd. But the smallest possible one here is 3. All right, then it says determine the domain and range. We're talking about our x and our y values. Looking at the odd function, they continue to go out and up and out and down, or out and up and out and down. So what do you know about the domain and range of these as you look left to right and up to down? They are negative infinity to positive infinity. What else could I have said?
Real numbers.
All real numbers. I could have said all real numbers. I'm going to put that here. You don't have to write it, but it is all real numbers. Questions?
I didn't get numbers. The letters.
The turning points plus 1.
The turning point.
Yep. There's 1. There's 2. Add 1. That's 3.
Oh, well.
So the turning point is how many curves?
How many times it turns directions.
Got it.
Okay. So let's look at an example here. These are a lot. You see why I'm not drawing another one. They're kind of chaotic. But I want to look at number 37.
So I have to draw that?
No. I want you to look at it on this screen. All right. A couple of things you note. Before we start answering the ABCD thing, what are some things you see here?
A lot of degrees.
It's got to be an even degree. It opens the same direction. What about its leading coefficient? If I asked you that. It's got to be positive. It's opening up. Anything else that you see before we answer those questions they asked us? Anything different?
So the domain and range is all positive.
Oh, we're going to talk about that. Hold that thought. Okay. All right. So A asked what?
The relative maximum.
The x values of and determine if they're relative mins or maxes of the turning points. All right. So just for sake of saying, you guys can determine that that's like 1, 2, 3.5, right? I don't have to show you those. So let's just talk about, we know that's the turning point. You guys know how to determine the x value. Is it a relative min or max? Min. What about this one up here? What about this one? This one? This one over here. Whoop, went off the screen. Min, right? All right, with me? That's harder than you think because that's small and that's big. And I'm trying to look at that and it's whoop. No, not that far. Okay, so we're determining the relative min or max. You could find the x values. All right. So then it asked me about the zeros. Where am I going to find the zeros? where it's crossing every time it crosses the x-axis, right? Everybody with me? All right, and then it asks about the smallest possible degree. So I've got how many turns? 1, 2, 3, 4, 5. So what's the smallest possible degree? 6. Could be? Or 10. But the smallest possible it can be is 6.
Why 8 or 10?
Because they're bigger than 6. And they're even. Does that make sense?
No.
No, why? Why can't we answer that?
Because, no, never mind. It's just, never mind. I just add 1 and you said degree, right? It's just the only thing.
That 6 is the smallest it can
Because
be.
if none of
And you
them-
said it was even.
Yeah.
Right? 6 is the smallest it can be.
Yeah.
And we already said it was even. So what are some even numbers that could be bigger than that it could be?
Oh,
8, 10.
12.
That's where we got those
Oh,
numbers
okay,
from.
okay.
Fantastic. See? All you had to do is talk about it. All right, now we're talking about the domain and range. I'm having this cramp, sorry. Now talking about the domain and range. When I look left to right, think about the parabola, right? It keeps going out and out and out and out and out. So left to right, I'm still all real numbers. Does everybody agree? But I start having this problem here with my range. I see that it goes forever up, but I see a lowest point here. Is everybody with me? So my range would actually be everything, all the y's greater than whatever that value for y is, right? -5, I believe, is what it is.
So how do we write that?
So you would say y's greater than -5, or you could say -5 to positive infinity, right? -5 to positive infinity for this. If it was flipped upside down, you would say +5 or negative infinity to +5, right?
So did it mean you're starting in -5? Or you start in positive infinity to
No, can't start with positive infinity. You're starting with -5 and going to positive infinity. You can only start with negative infinity. Is everybody with me?
Yes.
That's why if it was flipped upside down, we would say negative infinity to +5. Okay, but this one, because it starts in, we have positive infinity, we have to start with -5. We read from down to up. Okay, least to greatest. All right, any questions about that part? Understanding those. All right, let's look at one last thing then. Oh, earlier I started writing. They were like, we see like one letter. It's like, oops. All right. You ran out of ink.
Yeah. You're switching me.
All right, so on these, we're actually going to sketch a graph based off the information that they gave us. And all they gave me was x values, the zeros. So all I'm going to do is draw some x values there. And what I'm going to tell you about these is some of them, there's only one thing you could draw to match it. And some of them, there's multiple things you could draw to match it. Okay? They're fixing to knock on the door, so I figured I'd go ahead and walk over.
I have a quick question.
Thank you. I had something else to ask you. I don't know what it was. I'll remember as soon as he walks away. Or not. Oh, I've been recording that whole time. Oh well.